We're live. Welcome, everybody. We're going to give everybody 5 minutes to trickle in. So if you're in EST like we are, that would be 6:35. And in the meantime, let's have a chat with our lovely speaker. We have Sharif Kuza here with us today, the lead of Reshift, and sorry about that, and one of the OWASP Ottawa chapter leads. So, we were having a lovely discussion just before this about what you were following, your favorite podcasts, what your favorite security news or your interesting security news is right now. You want to continue that discussion?
Yeah, for sure. So basically, one of the things that I'm kind of like following very closely is the SolarWind breach. Um, to me, it is not just another breach; it is a breach to a couple of really high-profile security companies, right? And in the past, it was easy to blame that, oh, developers, oh, nobody's taking care of security. But these are security companies. I'm pretty sure they had a bunch of security controls, but somehow the hackers were a little bit smarter. So, being in the security industry, I have to think that the folks at FireEye and SolarWinds did a good job. Actually, the question is, what if the folks at FireEye and SolarWinds really did a good job, but still they were hacked, right?
Mm-hmm.
So that is the question that makes me really, really think. So that's one thing I'm interested in. Go
There
ahead,
was
Ophelia.
there was a slight request for you to adjust your camera so that people can see you better.
Oh, okay. Yeah, yeah, for sure. Yeah, that makes a lot of sense. Let me see here. Okay, you know what? I'm gonna sit differently. How about that? Is that better?
You're still slightly cut off.
How about this?
Perfect.
Okay. The view in StreamYard is also kind of like a mobile view.
Mm-hmm.
So I'm not sure if it's different. Yeah, I think I see the other view here. Yeah, I think let me know if that's not good. I'll change it.
Hopefully, we might also be able to adjust the layout in StreamYard so that it's more like
Yeah.
a
Let's see if I can.
horizontal rectangle. There we go.
Yeah.
Mm,
Okay. First
perfect.
time
That's perfect.
user.
Yeah. You're doing great over there.
uh, so yeah. Yeah, I think the consensus amongst the security community that I've seen so far is that we're actually quite lucky that it was FireEye who was part of the attack chain
Yep.
because they found it and they could tell us about it.
Hmm.
Because if it wasn't them, we would have like who knows how much longer it would have been
Yep.
persisted in the wild without anybody having found out. So
Yep. Yep. Uh, yeah. So that's one area. The other thing is blockchain. And I don't know if you guys are following, but I used to think of blockchain as a part niche, part just Bitcoin implementation. But then in the last, I don't know, 6 to 12 months, the use of blockchain has just exploded. Government started to implement it. There is a lot of implementation um, uh, outside of the cryptocurrency realm. People are using it for all sorts of things. People are using it to create games, for God's sake.
hmm.
Um,
Have you seen
so
any like any useful implementations so far? Like I've seen a lot of them trying to replace databases in funny ways, but um, there are actual very interesting use cases for blockchain that are fit for purpose. If you
the biggest one, like the like there's a bunch of, like, for example, Dapper Labs. I'm not sure if you guys heard about it in British Columbia. They raised $350 million, and they created basically NBA. Can't remember exactly the name of the game or the application. NBA something, MPA. can't remember. But the whole idea is people take shots of NBA games and they monetize it because it's really a good shot from a particular camera. I don't think they add commentary on it or not, but then using blockchain, it could be traceable. Integrity is maintained, and this way the creator makes money, NBA makes money, and obviously the Dapper Labs makes money. So I thought that's a super creative application, and that particular application made in revenue about $500 million since inception. So we're talking about serious serious revenue here for a company. I don't know how much of that is related to the blockchain as a technology. If I remove blockchain and added something else, would they have achieved the same success or not? I don't know. But
it's an interesting, legitimate use case. Yeah.
Yeah. So I started to think about blockchain and the like the interest attack vector for blockchain and how it, NBA Top Shot. Thanks, Justina. That it could add. And part of the challenge with blockchain is that there's a good amount of kind of like threat inside the algorithm itself, which is usually outside the realm of a regular pen tester like me, for example. Right? A mathematician would be the one who would be actually kind of look into the algorithm and figure out whether there's something wrong with the algorithm. So that's something that's kind of like personally interests me as well.
Well, thanks for letting us know, because that, I'm definitely going to look that up afterwards. All right.
Yeah, for sure.
I'm going to segue now, since I think we have everybody that would normally show up into our main event. So thanks everybody for coming to the event. Welcome to the OWASP June event. Just for those of you who are new to OWASP Toronto, we do have these every month, so please feel free to chime in, subscribe to the YouTube channel, subscribe to the Meetup channel, those types of things. Reach out to us via Slack. The other thing that for people who are not new to the channel and do follow us more often, we are moving to doing these events the second Tuesday of every month for at least the rest of this year, to make sure that we don't overlap too much with any of the other events. For example, OWASP Ottawa is exactly right now, or exactly at our normal time in previous months, so we wanted to space them out a tiny bit. So thanks again for coming. We do have with us Sharif Kuza today, talking to us about bringing order to static analysis security testing. And if just a couple of housekeeping notes before we do start, and I hand it over to Sharif, there is a event feedback form in the YouTube video description. If you would like to leave us feedback about these events, ask us to find speakers for specific topics, or if you would like to claim CPE credits and we need to be able to prove that you were at the event, please fill out the form, and we will at least have a record of you being here. Thanks. And then with that, I will hand it over to Sharif. Thanks for being with us.
Hello, thanks Ophelia, thanks Yofei, thanks for OWASP Toronto for having me. My name is Sharif Kusa. If you're wondering physically where I am right now, I'm in the basement at my house in OWASP, Ottawa, Ottawa, Canada, in Ottawa, Canada. Just a little bit about myself. I'm a software developer by training and by profession for about 7-8 years. Joined OWASP 2006, long time ago, and basically I really loved the area of application security. Soon after, I started organizing a funny story. So basically, I was a new immigrant to Canada. I wanted to. I didn't know anybody in Ottawa, so one of the best ways was to basically just start a meetup. It wasn't called meetup there, but an event. There was nothing. There was I was interested in security. The first thing that you would come across in 2006 in the web when you type in security meetups was OWASP. So I sent to the news group asking, hey, is anybody, is OWASP Ottawa still alive? I got an email back from the president of OWASP back then, 2 minutes later, saying, hey, nobody's, his name was Jeff Williams back at that time, saying, hey, nobody's organizing the meeting at OWASP Ottawa, you can start it. So I found a space, I found a speaker, my employer helped me find a speaker, and I got the first meetup organized. But it was a total embarrassment because I didn't know anything about security back then. People were talking about cross-site scripting, things like SQL injection, and I had no idea, zero, what they were talking about. So I was very proud that I was able to organize the first chapter, the first meetup, but I wanted to organize more meetups, but I cannot be ignorant. So I started teaching myself about security. One thing led to the other. I found myself writing the version 5 of WebGoat. One thing led to the other. I found myself writing questions for SANS and GIAC for their, back then it was new, GSSP Java and GSSP Net. I wrote about 500 questions. One thing led to the other. I found myself working in the security code review team for Wells Fargo, reviewing things like online banking and insurance and all sorts of stuff. In 2010, after Wells Fargo, I founded a consulting company called Software Secured, where we do penetration testing as a service to help small to medium-sized technology companies meet the like ship secure code. This is kind of like where pen testing meets DevOps. In 2009, because one company and 2 kids is not enough, so in 2009, I founded another company called Reshift Security. Anyways, without further ado, let's start with a question. Are we writing more secure code in 2021 or not? What do you guys think? OWASP has been around, depending on who you talk to, since 2003. You guys have been attending OWASP and probably other meetups. There's a lot of tools, there's a lot of courses, there's a lot of like maturity in application security. So the question is, are we writing more secure code in 2021? What do you guys think? Anybody? No? All right. I'll attempt to answer this question. It is complicated. I don't think there is a good answer to it. So I started looking for some numbers, right? So I looked at the number of CVEs between 2003, I think, no, between 1999 and 2019, right? So if you look at 07, 08, and 09 and compare it with 10 years later, so 2017, 2018, and 2019, it's more than double the number of CVEs, right? So basically, we have been adding more CVEs, although the industry theoretically has been maturing in a span of 10 years, right? But to be honest with you, that's not 100% fair. Why? Because we're writing more software, and basically, as you write more software, potentially more vulnerabilities are being introduced. It is just you write software, you write bugs with it. That's just the nature of life, right? And we're also releasing code faster than ever. Now, is releasing code faster would contribute to adding more bugs or not? Some people say yes, some people say no. If you're releasing code faster, there is no time to test software properly. But from the other end, if you're releasing code faster, you're also able to find and fix bugs faster. And according to a survey that's been done by GitLab, almost 83% of developers said they are releasing code faster and more often today than ever, thanks to DevOps. All right, so we don't know if we're writing more secure software according to the number of CVEs. We're not, but we know for sure that we're releasing code faster. So at least we must be fixing bugs faster, right? If we're releasing code faster, if we find that there is a bug, then it's not a big deal to fix that bug and push it to production much faster, right? Compare that to 15 years ago, where if you find a bug, too bad, you have to wait for the next release cycle. Right now, companies like AWS, Shopify, Facebook, they release hundreds of times a day, right? So we must be fixing bugs fast. Let's look at the data. In 2009, this is a report by White Hat. In 2009, the average time to fix was about, from this graph, it's about 2 months, 62 days, 65 days, something like that, right? 10 years later, 2019, same report from the same company. They unfortunately stopped categorizing it by bug, as in here, like they don't categorize by session fixation or cross-site exposure or what have you. They categorize it by risk category, so by criticals, by high, by low. But it didn't really change that much. 10 years ago, it was about 2 months on average. Now, it's a little bit more even. It looks like the average is about 90 days. So what happened, right? How come, while maturing in the industry, AppSec is definitely more mature than 10 years ago. We have way more tools. We have a lot more professionals right now, security professionals. How come we're not fixing bugs faster? First of all, why is that important? Why does fixing bugs faster important? Because for the very simple reason that it takes almost 10 times more to fix a vulnerability than to exploit it. So an average time to exploit a bug is between 7 and 14 days to exploit a bug. But it takes us about 3 months on average to patch a bug. So if this ratio 1 to 10 continues, then we have no chance against hackers, right? Doesn't really matter what we find. We're always going to lose because our average to patch is 10 times more our average to exploit. 10 times more the attacker's average to exploit. So what's going on? We are supposed to be shifting security left. We are, right? According to the same survey by GitLab, 65% of security professionals reported their organizations are in fact shifting security left. So if we are shifting security left, why are we not fixing security issues faster? Very complicated question. However, one of the things that I noticed from the same White Hat report is the average time to fix a DAST is even double the average time. If the bug came from a DAST tool, the average time to fix the bug is almost double the time, maybe 2 to 3 times longer to fix a bug that came from a DAST compared to one that came from a SaaS. So as if the average time to fix a bug coming from a SaaS was not bad enough, it's actually more time to fix a bug that came from a DAST tool. So, question for you guys: why do you think issues identified by SAST are fixed faster? See, if a bug that was found by a SAST is for criticals, it's almost 1/3 of the time that it takes to fix a DAST. For a high, it's almost half. For a low, it's almost 1/3, and so on and so forth. Why is it faster to fix a bug that is reported by a SaaS tool than a bug that is reported by a DAST tool? Any takers? Until I get the replies, until I get your insights, only 24% said their companies have static code application security in place, right? Could this be contributing to the fact that it takes 10 times to patch a vulnerability than to exploit it? So it takes 10 times to, on average, 90 days. Is that why? Because there's a lot of companies that are not using static code analysis in their pipeline. So why SAST? I'm not sure if anybody has has answered, but I took a look. I'm a little bit biased, obviously, but things that we can basically think about is it's easier for developers to understand. It's easier for developers to use. A lot of developers think about it as an alternative to or similar, basically to a similar tool to a linter, right? It gives you the exact line of code. It's usually earlier in the software development lifecycle. The evidence is the exact line of code. So when the tool generates a report, the evidence of a SaaS tool is the line of code, and the developer can understand that. This is a language that the developer can understand. Compare that to another tool such as a DAST, for example, where the evidence is a request and a response. That doesn't tell the developer where exactly is the problem, right? Finally, usually SaaS tools provide remediation that's a little bit more relevant than a DAST tool. I have a problem with both not being able to provide actionable results to developers, but on average, the remediation is more relevant as it understands the language. So at least put remediation advice in the language where that matches the code scanned, etc. Any questions so far? Okay.
There are no questions, but there are a lot of comments. There were a couple of people who did answer what you were saying about why SAST. There's also a couple of comments about SAST finding things earlier in the life cycle, and hopefully that being easier to fix since it is earlier.
Yep. Yep. I don't know if developers are, I don't think developers are running the SAST. That would be another reason why SAST is faster to fix. But maybe they are, maybe they are not. But definitely it's easier for developers to understand exact line of code, as well as remediation is more relevant. I see here Magnus Sands said SAST finds it earlier. The earlier you find it, the faster and cheaper it is. Absolutely, absolutely. All right, so let's take one of the things that is kind of like a dirty secret about SaaS is that there's not. It's a lot of people look at it as dull. A lot of people look at it as lots of false positives. A lot of people look at it as slow, which all is not wrong. Most of this is probably true. I dealt with the SaaS tools for a long time. During my time at Wells Fargo, this is all what I was doing, is basically looking at results from a particular SaaS tool. All right, so let's. So I picked JavaScript just to have kind of like a case study to understand how would a SaaS tool typically look at source code. What are the differences? What are the challenges that, in order, if you want to write SaaS tool tomorrow, what are the challenges that you're going to find? And just out of experience, just navigate and take a case study of something like JavaScript. So let's look at JavaScript and what's going on with the JavaScript ecosystem. JavaScript today has exploded to about 12.4 million developers worldwide, right? By far, it is the most popular language today, 2021, right? And by a good margin. The second popular language is Python, and there's a 3 million developers gap between JavaScript and Python. So JavaScript is the #1 clear winner, right? That's not the most important piece of information. The most important piece of information, that 5 million of those joined the community in the last 3 years alone, right? So almost half the JavaScript developers worldwide that we have today just joined the community in the last 3 years, right? So it depends on how you look at this. You look at it as a JavaScript is great. You can look at it as immature. You can look at it as there's a lot of newbies in the JavaScript realm. So definitely the security of that ecosystem is so interesting, right? Speaking of ecosystem, the ecosystem has exploded, obviously, because of the sheer number of use cases, the sheer number of developers worldwide, etc. From JavaScript flavors, TypeScript, PureScript, ECMAScript, ClojureScript, and you name it, to the front-end frameworks, to the data layer frameworks, to the back-end layers. It's a lot. So what are the characteristics of JavaScript? How is JavaScript different from other languages? I'm not going to go very deep into this, but just to understand, Benjamin Pierce, who is one of the authors, he's the author of one book on type systems, very famous book called Types and Programming Languages. Types and Programming Languages. He classifies programming languages along two axes, whether they are safe or unsafe, and whether they are statically or dynamically checked. A safe language is a language that protects its abstractions. For instance, the runtime cannot be corrupted by writing past the end of some memory regions, right? So based on this, Java is considered a safe language, while C, C++ is considered unsafe. So that's the first axis, safe, unsafe. The second axis is static versus dynamic. And a statically checked language is a language that ensures the safety of its abstraction, the safety of its types at compile time. For instance, by checking that all variables are initialized before they are used. Or you cannot convert from two uncompatible types, things like that. Now, JavaScript is an interpreted language, doesn't have a compile time. So there's no way to check that, to check for static types. In this case, the runtime will check every operation to ensure its safety, right? Hence the extra use for something like static code analysis in general. That being said, JavaScript is both dynamic and might be it's safe, as in the fact that you cannot write past a certain memory. You don't have access to pointers. But let's look closely at the unique nature of being a dynamic language, and whether this unique nature of JavaScript make it vulnerable to even unique attacks. From an OWASP top 10, JavaScript inherits all of those vulnerabilities: injection, broken notification, sensitive data exposure, XXE, deserialization, broken access control. It got all of that, but just like any other language, right? Even insecure deserializations through something like JSON deserialization, for example, right? However, JavaScript adds unique vulnerabilities that does not exist in almost any other language. Let me give you guys a quick overview of this, right? Let's look together and take some, this is my console here. Let's explain how JavaScript is a classless object-based language. So it is object-based, but not based on a class. And we'll explain why does that matter. So let's say, let's say that you have something called shape, right? And this shape has a name. Let's say the name is a circle, and a function called toString that basically is a function, and this function basically just returns the name, right? Pretty simple. Okay. So I'm missing something somewhere. Version name toString function return. Oh, this return this dot name. Cool. All right. So basically, if I did shape toString, it basically will return a circle, right? So basically, this guy just returned whatever is in name. Cool. Cool. So what just happened? I don't have a class, just like Java or C# or C++. I don't have a class. However, JavaScript allows you to create just an object right away. All right, cool. What's the problem with that? Is you can change the parameters. You can change that object on the fly at runtime, right? So for example, I can do something like this: shape.color. Notice that I didn't define what's going on. I didn't define color in var shape, but I can define it after. So I can say that I can add color. I can add a property called color and say this is red, right? And I can add an accessor to color. I can add a function equal function b, and define this function is this dot color equal b, right? And if you and now shape dot get dot color, if you call that, you will find it's red. But now I can call it set dot color, and I can say blue, for example, right? And now call shape dot color again, and now it's blue, right? So what just happened, right? This basically, it creates a shape object, no class, with a field specifying the shape name and a toString. And then after instantiating the object, I can still change that shape dynamically, right? Great. That's fine and dandy so far. JavaScript is also weakly typed language, so it can allow me to do something like this: function add x plus y. Function add, it takes two parameters, x and y, and it basically returns x plus y, right? Now, here's the thing. What is the type of x and y? Undefined. The type is undefined right now. Okay, great. So the return of add, what is it gonna be? Not known. It's basically 100% dependent on the parameters that are being passed to the function. So for example, if I did this var a equals add 1 and 2, in this case, basically, and you say type of a, so a is a number, y, I didn't define a, I didn't define x and y, so why a is a number? Only because 1 and 2 are numbers. Now, if you do var b equals add, let's say OWASP and Toronto, right? And you say type of b, oh, it's a string, right? So this is what I mean by a weakly typed language. This is why I mean by a weakly typed language. So, okay, Sharif, great. Yeah, that's so what's the big deal? Why does that matter, right? It matter because this nature could lead to vulnerabilities that are based solely on type manipulation. Let me show you how, right? Consider this this piece of code. Let's focus. Let me get my pen here. And let's focus on the left-hand side first, this part first. So what's happening here, just very, very quickly, it kind of creates a web server. It creates a server, right? And request handler, what it does is request handler parses the request, takes the URL piece of the request, puts it into something called parsed URL, and then it takes the query string out of the URL, puts it into something called user input. It passes that it passes that user input into a function called sanitize, a particular parameter in the query string, not the whole query string, only a parameter in the query string called foo. And then it takes the output of sanitize and return it back to the response, right? Cool, cool. All right, what does sanitize do? Let's look here. So sanitize is here. Sanitize, what it does, if the type input is string, right, it tries to look for cross-site scripting control characters, which is less than, greater than, and ampersand. I know that there's a whole bunch more than these three, but just for simplification of the code, let's just assume that it is just those three. right? So if the type is string, it tries to match if the input is one of those, and it replaces them with their corresponding HTML safe characters, right? So kind of like it's doing output encoding, if you will, right? It's doing output encoding, if you will, right? Anybody can see any problem with this code? Well, let's test it. So if you pass server like HTTPS, blah, 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 foo equal bar, keep in mind that the code is going to look at foo only. It returns back bar. So that doesn't tell us anything because there are no control characters in bar. All right, let's actually test it. So let's pass in a couple of control characters, which is less than and greater than, which are definitely characters that are used in any cross-site scripting payload. So what the output that we will get is ampersand less LT semicolon and ampersand GT semicolon, which is the equivalent, the HTML equivalent of less than and greater than. Well, that's good. So the code is doing actually what it's supposed to do. Let's test it with a real cross-site scripting payload. So this guy right here. So the output is basically this. So it looks like it worked very well. Awesome job, right? Not so fast. This code can easily be bypassed. I'll show you how. If you overload the parameter, so basically pass two foos instead of one, so overload the parameter with two, and the output will not be sanitized. Your sanitization method will be completely bypassed. Why is that? Because basically, when we do this, when you parse query and you pass in .foo to sanitize, now it's not one value, it is two values. So JavaScript is going to look at this as an object because now it is not one value, it is two values. So I'm going to think of this as an object. So the first if is not going to kick in because that type of input is not a string anymore. It is actually an object, right? It's an object because the foo was overloaded, right? So this is one just very, very simple way of bypassing some code just because of the nature of JavaScript. Any questions so far? All right, cool. Let's look at another interesting JavaScript feature, which is prototype. JavaScript is considered a prototype-based language. What are prototypes? Prototypes are basically a mechanism in JavaScript by which JavaScript have some inheritance features, right? So, you know, inheritance in other languages such as Java or C# or C++, basically there is a class, and then you create another class that inherits from the original class, and then you create an object from that class. But because we don't have classes, but we want to have inheritance. So the creators of JavaScript did not want to have classes, but they wanted to have inheritance. So how do we do that? So they said, oh, you know what? Let's do prototypes. So prototypes are basically an object that is included with every single JavaScript object that you create. So basically, every single object that you create in JavaScript will have a prototype object, which acts as a template object that inherits methods and properties from. And basically, this is how you can share properties between one object and the other, right? And now there's something called prototype chain, which basically the prototype chain is how different objects in JavaScript can share properties and methods with each other, right? Similar to how Java, as close as possible to how other languages would do it, right? So let me give you guys a quick demonstration here of what I mean. So let's say that I have something called shape, right? And count of the shape is 1. Count of the shape. What did I do wrong? Oh, sorry. count of the shape is run. I might still have something. Yeah, of course, is 1. Cool. Now I can do something like this, right? Now, oh, 1 second before I do this. Let's say my shape dot name undefined. Well, that makes sense, Sharif, because I didn't define anything in my shape called name. So it's okay to have undefined. But let me show you this in JavaScript. What can happen is I can define undefined, right? I can define undefined and say, hello, right? Great. So now let me repeat this. My shape.name is still undefined. What did I do wrong? The gods of the demos. Output my shape.undefined equals hello. My shape dot. Oh, I'm sorry. So my shape of my shape dot name. My shape. Yeah. Hello. Right. So what just happened here? What just happened? My shape is still undefined, right? My shape dot name is still undefined. However, because I define my shape of undefined, so now this is equal to my shape of undefined, but I actually defined undefined, and now undefined is equal hello. You see how crazy JavaScript is, right? Any questions? Did you guys get this, or should I repeat it? I can see. So let me see the comments. Did you guys get this? I was able to basically define things in JavaScript as deep as just the value of undefined, right? This is what I was able to do, right? So why does that matter? What is the big deal? Let me show you something. Let's say that I have something called customer. Okay, I have it here. And customer has a name, person, and address. Let's say 1 Main Street. Cool? All right. Now, let me show you what I mean by prototype for those of you who don't know what a prototype is. So as I said, every JavaScript object have a prototype object. In this case, it's Notion by __ proto __, right? And if I have access to the prototype object, which every JavaScript object have a prototype object, if I have access to the prototype object, I can define this object the same way I defined something called undefined, the undefined value inside JavaScript. In this case, if I did something like this, right, where I basically inserted alert into the prototype object, the toString of the prototype object, guess what I will have? Now, if I called customer.toString, there you go, right? Hey, what just happened? First of all, customer did not have, when I defined it, it did not have a toString function. That's number one. Number two, I know that we just injected the toString of the prototype, but what I called here is customer.toString. So what is going on? Here's what's going on. So what's going on is that because I was able to inject into the prototype the toString function of the prototype object, and when I called customer.toString, although customer, it's the object customer itself does not have a function called toString, it just called whatever exists in kind of like the parent class, which is the prototype class, which I was able to inject JavaScript into, right? So this is basically a bug called the prototype pollution, which basically if the attacker found a way to inject directly into the prototype, now regular functions that the JavaScript objects are calling could also be polluted by whatever the hacker was able to inject into the prototype object. And now here I was able to execute a cross-site scripting attack, as you guys see in this pop-up here, but I can also do command execution. I can do a bunch of other things. Any questions so far? All right. I'll keep monitoring. Keep the questions coming, folks. I'll keep monitoring the chat here. Are you scared? By the way, are you scared from JavaScript yet, or not? Are you scared from JavaScript yet, or not? So how do you find these? How do you find these security vulnerabilities? How do you find these things? I mean, the number of ways that you can find a particular security vulnerability, whether JavaScript or not, are not a lot. You can do security code review, linters, static code analysis, other tools such as DAST and IST. David said, "I love JavaScript." I love JavaScript too. I love JavaScript too. It just scares me a little bit with all of the crazy things that you wouldn't think could happen. I find that the people who started their software development career with JavaScript have a totally different view than people who started with another language and switched to JavaScript. I'm the one who I'm a person who started with C++. I then did Java, then did .NET, and then later in my life I did JavaScript. So that's why maybe I'm a little bit alarmed by what JavaScript can do. All right, so let's look closely at SAST. SAST is a very, very complicated subject, but just to simplify it for our sakes, what SAST does, it takes, let me get my pen. It takes a piece of source code. It extracts a bunch of information from that source code, put it into some kind of intermediate representation. In a lot of cases, it's an AST tree. An AST tree is exactly what the name suggests, abstract syntax tree. What does it abstract? It abstracts basically the specifics of the source code. It abstracts a bunch of information and just focuses on the information that the analyzer needs, and it builds it. And if you look at the AST tree, it actually looks exactly like a tree. And then it uses a bunch of rules to navigate this tree, which is what the analysis is, to provide you with the results. Right now, things like linters stop here. Right, things like linters do not go into something like call graphs. Why is call graphs important? Call graphs is important for a lot of things. One of those things is the ability to follow a taint from one file to the other, or from one function to the other. So, for example, if you have a taint that is a taint is basically a payload, for example, that user input, that's a taint, right? So if the user input is retrieved in one file and then passed into a function that exists in another file, something like a linter cannot follow that through. Why? Because they don't do call graphs. Call graphs is that notion that follows the taint across functions, across files, etc. Right? So that's what a SAST tool can do. It follows the taint and does call graphs and whatnot. Right? One of the problems with regular SAST tools is that you cannot teach a dog a new tricks. Anybody of you, how many of you wrote a SAST rule before? For anything, even for a linter, for something like, I don't know, ESLint, for something like find sec bugs, for PMD. And even the more security specific static code analysis, Fortify, checkmarks, etc. All of those guys allow you to write rules. Anybody wrote rules before?
Yeah, for my sins, definitely.
You did,
Yeah.
Oh, how do you think of it?
Some tools are easier than others, definitely. But we're not that far off from like the old days of writing regular expressions for firewall rules.
Yeah. It's David wrote for ESLint. What do you think, David, writing a rule for ESLint? How was the experience?
Pain.
The
writing is not the problem, it's the testing.
Exactly. For everybody else, let me show you what a tool looks like for ESLint, right? Here you go. So this is for object injection, by the way. Right. This is one rule, right? Why the rule writing for regular static code analysis is a pain? Because imagine that you're trying to write a query without SQL. Imagine that you're trying to write a query in Java without the use of SQL. How would that be? You got to model each table. You got to do the relationships yourself. You got to do the where clause yourself. You got to do the ordering yourself. You got to do every single thing yourself. That's exactly what a rule writing would look like for most tools. Hence, it is obviously not the best experience ever, right? All right, so shifting security in general, and because we're talking about JavaScript security, shifting JavaScript security in general, two things. Everything that I'm going to mention, I have 6 points coming up. Everything I mention is not particularly for JavaScript, just because we're talking about JavaScript, it makes sense. And you can apply that even if you're not using Reshift or using other tools, not using static code analysis in general. These are concepts that can be applied using any other tool, basically. And these are basically stuff that I learned throughout my career, starting from 2000 and 2008 when I started my security career. 1, break the SecDev barrier. Break the SecDev barrier, right? Developers and security don't like the relationship, and it started to improve, but in a lot of companies, it's not the best, right? For very simple reason, security folks are creating more work for development folks. Plain and simple. We go find bugs, send it over the fence for developers to fix it. Right? Who wants that? Like, who wants other people to just pile work on their desks? Nobody wants that. That's exactly what we do as security people. Think about it, right? We tell ourselves other stories, like we're securing the organization. What the developer, what they're looking at, what they see is somebody who is creating more work for me than I'm being paid for. That's just the truth, right? David says security folks always say no. Exactly, we love to act as the police, right? For good reasons, but we do act as the police, right? In order to succeed as a security professional, you gotta break the SecDev barriers. You have to look as developers as the folks that are creating kind of like in a bee colony. They are the ones that are creating the honey, right? They are the ones that are creating the honey. If the honey does not get out of the colony, if we cannot use the honey, then the whole colony is not functional. And security folks are preventing the bees from creating honey, right? So if we cannot, as an industry, change that perspective, we're always going to be status quo, right? So how can we break the SecDev barrier? The answer, unfortunately, is it depends. But here are the basically great stories that I heard from people who were successful in breaking the SecDev barrier. From one team, I heard that, hey, you know what? When we start working with a new development team, the first thing that we do is not to report a vulnerability. The first thing that we do is fix a vulnerability that we find. So the first patch of vulnerabilities, I'm not talking about hundreds, I'm talking about just a few, a handful of vulnerabilities, we do not report them. We just go and fix them right away in the code. This way, we gain the respect of the developers. And now they are willing to listen from this point on, right? That's one team I heard from. Another team that I heard from is, we made security folks more approachable. I said, how? That was before COVID. I don't know, but after COVID, what do they do? But before COVID, here's what they do. They were in the same building. We said, we put chocolates. So chocolates? He said, yeah, people come and grab chocolates. It creates a conversation. Hey, what do you do? Et cetera, et cetera. Hey, I'm David. Hey, I'm Sharif. Hey, I'm Yukfei. Yeah, how are you doing? And now we're humans. We're not that guy sitting behind the screen just sending a bunch of those, as David said, or sending a bunch of bugs. I'm an actual human. I'm approachable. I'm nice. We can talk. What do you think? And the chocolate brings a conversation. The conversation brings security. Security, now we could talk about security, breaking the security barrier, right? I'd love to listen if any of you guys have any good stories about breaking the security barrier. These are just two stories that I've listened. One more story until folks start contributing. One more story is, this is a client of ours on the software security side. I think we gave them training, and OWASP Top 10 training, normal OWASP Top 10 training. And then I followed up with them 6 months later, said, hey, how's it going? He said, it was great. Obviously, my ego said, great job, Sharif. You did a great training. It wasn't because of my training, but what happened is the training led a few folks talk more than others about security, right? And this helped my client, the VP of engineering, to identify security champions that he can rely on to push the whole team, right? And there's nothing better than developer folks that take the hat of security and convince other developers around them, right? So your best bet is to find and cultivate security champions that can work with you, because developers listen to other developers, less so to security people, unfortunately, but that's the truth, right? So that's another way to break the SecDev barrier. Lower the education barrier, right? You go give training, you tell developer, you spend the whole day explaining OWASP Top 10, here's SQL injection, here's cross-sensitivity, here's XXC, here's deserialization, et cetera, right? 2-3 days forward 2-3 days, you send SQL injection to the developer. Do not expect that they will actually remember what that is. Do not expect they will retain probably at best 10% or 15% of the training that you gave them, right? So, and do not expect them to remember everything that you said or anything like that. I'll give you an example. If you're a developer, you know this. Nothing annoys developers more than a bug that does not have all of the information, right? What is the scenario of reproducing this bug? What is the platform that it was created on? When did that happen? The more information you give about the bug, the faster you get a resolution for this bug. Why would security bugs be any different? So you send them a bug about SQL injection, you tell them, here's this line, it has SQL injection, blah, 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 fix it, right? Try adding a lot of other information about SQL injection. You can template that, right? You can template that in your library and give them everything that they need. They give them an overview of SQL injection, give them how to fix SQL injection in the stack that they are using, give them a bunch of scare stories from companies that really had a bad SQL injection experience, and look at the difference that makes. I know for the sake of time, I'm just going to speed up through these. Real secure coding starts in the IDE, not the CI, right? So as industry, we're doing a little bit better in the sense of we start shifting security left. According to a survey that was done by GitLab, 65% of security professionals said that we're shifting security left. In our head, when you read this report, you would think that, hey, like security tools are running in the IDE, they're running in the CI, they're running on pull requests, they're running everywhere. No, that's not the case. When they probed a little bit, basically what happens is that instead of running the security tools after release, they are just running it on a monthly cadence. or on a bi-weekly cadence, right? The best companies that I've seen are running it in the IDE, in the CI right now. Let me tell you a little stat. Google did an experiment between 2006 and 2009 and applied regular static code analysis across the board. Every single developer at Google between 2006 and 2009 were using regular static code analysis. Here's what happened. 74% deemed issues flagged at compile time as real problems, right? 70% of the Googlers, if they saw the issue at compile time, meaning at the IDE, inside the IDE, they thought that the issue is a real problem. And that percentage dropped to 21% after the code is checked in. Exactly same problems, exactly the same people. You show the problems to the people inside the IDE, they consider it a real problem. Move that later to after they check in the code. No, that's not a problem anymore, right? And you can see the bias. The bias is so obvious. The developer want to be done, want to move already when the code leaves their machine. They are emotionally done with that code. They want to move on to the next task, right? So real coding starts in the IDE. Now you might not have the capacity, or your tool doesn't really run inside an IDE, or it's too slow, or what have you, right? Providing a checklist for developers to think about before they commit their code. Think about creative ways where developers can think about issues before the code leaves their machine is key to shifting security left. Next is scanning speed and stage. Some tools are slower than others, right? Some tools are slower than others. One thing about shifting security left is you have to understand whether the tool that you're using right now is capable of actually meeting the stage that you want to run at. So some tools are too slow to be run in the CI. Why am I saying this? Because if you do introduce that tool inside the CI, it's going to fire back, right? If the tool takes more than a handful of minutes inside the CI, it is going to be pumped out because it's slowing the developers from going to production. It's slowing the bees from taking the honey to where it should go. It's slowing the bees from producing even honey, right? So the more left you want to go, the faster the tool that you have to pick. Otherwise, it is going to be deemed too slow and wouldn't be used. For example, at Reshift, we achieved speeds of approximately 10 milliseconds per line of code. Because Reshift is created mainly for developers, and we know how speed is really, really important for developers. So you have to look at the tool that you're using. If it doesn't fit, then don't try to introduce it. Otherwise, it's going to fire back. I'm not going to go into that. Next is precision over recall. So us security folks are obsessed with recall. By the way, precision recall are two concepts of static code analysis. Recall is if I have 100 bugs in a piece of software, recall is the measure of how many of those 100 bugs is the static analysis tool or any tool is able to find, right? Precision is out of the ones that are found, how many of them are actually real bugs, are true positives, right? So static code analysis tools in general and security folks in general are really focused on recall, are really focused on finding as many bugs as possible. But your client, which is the developer, does not care about recall at all. They care more about precision. So if you want a tool that you are going to use, feel free to use whatever you want. If you want a tool that the developer is that you're going to give the developer, you have to make sure that the precision is as high as possible. Why? Because the developer is not going to look at those as kind of like pointers. They're going to look at them the same way that they look at bugs. And if the bug is not proven, then it's not worth their time to fix it, right? It's not worth their time to fix it. They lose trust with the tool that is generating those bugs. Finally, measure. It's funny. In 2021 and like even the last decade, we're like as an industry, if you're working in SaaS, you're working in technology in general, we're obsessed with numbers. We're obsessed with data-driven decisions, except in AppSec, right? The only number that we care about in AppSec is whether we're meeting compliance or not, right? And we miss the opportunity to improve a lot what we're doing. We missed the opportunity to improve our security spending. We missed the opportunity to improve where should we fix. We missed the opportunity to apply really custom training that focuses on improving our KPIs. In my opinion, there is very few KPIs that should be measured. One of them is the number of vulnerabilities per risk categories, and the average time to fix, which should be your key metric. Average time to fix for SLAs, for compliance, for your own sanity. Average time to fix. The number of vulnerabilities per security activities. How many am I getting from my code review activities? How many am I getting from my SaaS tools? How many am I getting from my DAS tool? So you can understand exactly where you should put your budget, where should you put your focus. And finally, the number of vulnerabilities per stage. Am I finding more vulnerabilities inside the IDE? Am I finding more vulnerabilities in the CI or after production? And why, right? And again, the number that you should be focusing on as an industry, we should be focusing on is the average time to fix, right? Because if we still, our average time to fix is more than the attacker's ability to hack, we'll always be losing, right? Finally, if anybody would like a demo to Reshift, which is a developer-first security tool that makes it really easy for developers to shift application security left, just reach out to me and I'll be glad to arrange a private demo. That's everything that I had, folks. Please let me know if you have any questions.
Thanks for that. That was a very fun presentation, mostly because you started in on the demos, and I'm just like, oh, live demos. Amazing. Brave man.
The JavaScript demos?
Mm-hmm.
Oh, those are easier fire. I mean, yeah. But for sure, I mean, I had lots of demos that went bad, so.
That's what I mean. Brave man.
Appreciate it. Appreciate it. Thanks, David.
Well, we're kind of here. Was there anything in the presentation that you would have added if you had more time or had no restrictions?
I'm obsessed with numbers, so I would have added more numbers to understand, are we writing secure code? Where's the problem? That's one thing. I would love to add, some people in the previous, I gave this before, so some people asked me, hey, how about TypeScript? How about React? Hey, React solves this problem. TypeScript solves this problem. So I want to put examples from TypeScript where it had its own madness, from React where it has its own madness. And finally, obviously, I would love to show you guys Reshift because obviously I'm biased, but I know that that's not the subject of this presentation.
Sure. If I do have a question just about the approach that you talked to us about. So if I understand correctly, you're saying that scanning in the IDE is preferable because it's faster and it's also where the developer is working, so it's easier for them to understand and to fix the issue, right?
Yeah.
So how do you approach the other ideas in static code analysis of creating, let's say, a call graph? If you don't have the other components, for example, in your IDE.
Are you saying that you are using a static code analysis that does not have an IDE plugin, or they do, but it's not great?
No, I'm saying, let's say in the IDE you only have a subset of the files, if you will, or do you need to have all the code that you want to analyze loaded in the IDE for you to be able to build the call graph?
You do not need, so a typical tool would not need to have all of the files in order to be able to build a call graph. If there are files missing, just the call graph is not going to be complete, but it doesn't mean that it's useless, right? So the call graph is not going to be complete, but it's just, you just don't have the whole map. Like, let's say that you need a map to go, you don't have the whole map. So it will try to, a good tool, a really good tool, will try to make assumptions about the pieces that are missing. That's a really good tool. So even if you have files missing, it will make educated guesses, but this doesn't mean that it's not going to do a good job.
Gotcha. Okay.
Okay. We do have a question from Dave P. He asks, what sort of validation strategies are there for static analysis tools, and how would I best develop confidence in a SaaS solution?
That's a good question, Dave. So there's a few things. WASP has a project called WASP Benchmark. My only take about that is the bugs that are there are very, very specific, but it's one data point that is definitely worth trying. A WASP benchmark project. That's one thing. What I would do is take a bunch of, let's say, JavaScript. There is a bunch of well-known vulnerable JavaScript projects: Juice Shop, DVNA, Node Goat, I think. Right? There is a bunch of. We developed one called Durian. Sneak has one called Goof. And the bugs are known. Pass these into the tool. See if it finds the bugs that you know are there, right? And see if it finds the bug. That's the first stage. The second stage is run it against your own code. And I'm assuming that you know the bugs in your own code. At least you know some, if it can find those bugs or not, right? And the other angle of this, it finds a lot of noise. If the noise to find things is high, then that's not a good indication. Does that help? Until I hear back from Dave. Anybody else has any questions? Yeah, you're welcome, Dave. Yeah, Ali, definitely they smiled on me today. But hey, I put easy examples, so I didn't put complicated code. But yeah, definitely. Anybody else has any questions?
There's a question from Tensor.
Yeah.
I apologize if I've mispronounced your name. And he asks, do you need to compile the code to do a SAS scan?
It depends on the tool. So, for example, something like Fortify will need it works on the compiled. Fortify and Veracode, if I'm not mistaken, will need the compiled versions. Linters in general can operate on the source code. Checkmarks operate on the source code. Reshift compiles the code but doesn't need the compiled version. So it's kind of in between. It compiles the code for Java, for example, but it does not work on the binaries. It just looks at some of the calls. I mean, I don't want to go into reshift, but the answer is it depends. Some tools do, some tools don't. And that might be that might be one of your requirements, whether you don't have access to the binaries. In this case, you need a tool that runs on the source code, and there are a bunch that runs directly on the source code. The only thing I will draw your attention to is it might miss a few things if it doesn't run on the compiled version, or doesn't even attempt to compile the code. It might miss some stuff.
Yeah, in general, the tools that are compiling the code or trying to compile into an intermediary language so that it can build the call tree and the what's it called, the execution tracing models. And the ones that don't tend to run more regular expressions against things. And so, like, if you're familiar with regular expressions, you know how limited some of that can be. But if you are running either a compiler or it compiles the code itself, then it'll usually compile it with certain flags and things like that, so it can reconstruct a model later, or can construct an object representation. So that's actually a lot of what takes so much time in the static analysis tools.
Exactly.
That's why it takes bloody forever, and it also takes so much disk space, and memory to construct these models and run the test cases against that.
That's an excellent answer. Thank you.
Too much time spent with these tools, you can tell.
Yeah, I can see the pain as well. All right.
Any other questions from the audience? Any other tidbits of wisdom that you'd like to share with them, Sharif?
No, I think you guys have enough of me today. Thank you so much for taking 1 full hour of your day and listening to me. And thanks a lot again, OWASP for having me. It's always an honor. I appreciate it.
Pleasure.
Thank you very much. Thanks a lot, Yukfei.
Okay, thank you, everyone. I appreciate your time. Please remember that we'll be having our next meetup on the second the second Wednesday of next month as well. You will see the notification for that coming out on Meetup fairly soon. And then I think it's next week. OWASP Ottawa has their event, so. Feel free to chime into that one as well. They've already started publishing it too, and it should be a good one.
Sheriff, can you tell us a little bit about the event next week?
Yes. You caught me off guard.
Sorry there.
No worries. It is about, I have it here in front of me, just 1 second. So basically architecting for security in the cloud, and basically Josh Sokol, you guys, I'm not sure if you guys know Josh Sokol is I think OWASP chapter leader. He has been on the board for quite some time.
It's very active.
Yeah, he's very active, and basically just architecting for security in the cloud. So I'll post the link in.
I posted the link to the meetup.
Perfect. Awesome. Thank you very much.
No worries. And I also think earlier in the chat, we posted a link to OWASP Ottawa's YouTube channel. So they've been really diligent even before the pandemic in video recording any speakers that would allow them to. So if you want to go back and look at their history of some of the great speakers that they've had and some of the talks that they've had, please do that. It's there in their history. It's a great resource. So awesome.
Awesome.
Well, thanks to everyone. See you again next month. And thanks to our global sponsors and to you, our audience. Thanks.
Thanks everyone. Have a great night.
Thank you. Take care.
Bye. Bye.